many classifiers in scikit-learn can provide information about the uncertainty associated with a particular prediction, either by using the decision function method or the predict proba method. When given a set of test points, the decision function method provides for each one a classifier score value that indicates how confidently the classifier predicts the positive class. So there will be large magnitude positive scores for those points. Or if it predicts a negative class, there'll be large magnitude negative scores for negative points. Here's an example in the notebook showing the first few instances from our classification problem using a logistic regression classifier. We can see that instances in the negative class often have large magnitude negative scores. And indeed, the instances in the positive class have positive scores from the logistic regression classifier. Likewise, the predict proba function provides predicted probabilities of class membership. Typically, a classifier would choose the more likely class. That is, in a binary classifier, the class with probability greater than 50%. Adjusting this decision threshold affects the predictions of the classifier. A higher threshold means the classifier has to be more confident in predicting the class. For example, we might predict class 1 only if the estimated probability of class 1 was over 70%, and this results in a more conservative classifier. Here's an example of getting these prediction probabilities for the test instances for the same logistic regression classifier. You can see that many entries with a positive label of 1 have a high probability like 0.995, while many negative label instances have a very low prediction probability. Note that not all models provide useful probability estimates of this type. For example, a model that was overfit to a training set might provide overly optimistic high probabilities that were in fact not accurate. Now we can use these decision scores or prediction probabilities for getting a more complete evaluation picture of a classifier's performance. For a particular application, we might pick a specific decision threshold depending on whether we want the classifier to be more or less conservative about making false positive or false negative errors. It might not be entirely clear when developing a new model what the right decision threshold will be and how that choice will affect evaluation metrics like precision and recall. So instead, what we'll do is look at how the classifier performs for all possible decision thresholds. This example shows how that works. On the left here is a list of test instances with their true label and classifier score. If we set a decision threshold, then all the instances above that line, so for example, if we set the decision threshold to be -20 here, then all the instances above the line are below the threshold of -20, so -20 or less. And all the instances in this direction are above the threshold of -20. And so the ones below the threshold will be predicted to be in the negative class, and the ones above the threshold will be predicted to be in the positive class. So if we pick a specific threshold, so in this case -20, and we partition the test points in this way, we can compute precision and recall for the points that are predicted to be in the positive class. So in this case, we have 12 instances here, 12 total instances that are being predicted as positive, and only 4 of them, this one, this one, this one, and this one, are actually positive. And so the precision here is 4 divided by 12, or approximately 0.34. The recall, on the other hand, there are 4 positive labeled instances in the whole set of test examples here, and we found all of them with this particular threshold setting. So the recall here is 4 out of 4. We found all 4 positive labeled examples. And so for this particular threshold of -20, we can obtain precision and recall score for that threshold. Let's pick a different threshold. Let's look at what happens when the threshold is -10, right here. So again, Anything below this line is treated, it has a higher value than minus 10 here, so those would be treated as positive predictions. Things above the line have a score below negative 10, so these would be predicted to be negative. And again, we can compute a precision and recall for this decision threshold setting. And we can see here that there are a total of 6 instances in the positive prediction class, of which 4 are actually of the positive class. And so the precision here is 4 over 6, or about 0.67. And again, the recall here is going to be 4 out of 4, and it's going to be 1.0 again. And so that corresponds to this point in the table over here. And then as we're computing these different precisions and recalls for different thresholds, we can also plot them on this precision recall chart. So the first pair of precision and recall numbers that I got, 0.34 and 1.0, we can plot on this point in precision recall space. The second example, so this was for the threshold of minus 20. When the threshold was minus 10, we got precision of 0.67 and a recall of 1, corresponding to this point that we can plot. And so you can see that if we do this for a number of other thresholds, for example, the threshold of 0, we'll get a precision of 0.75 and a recall of 0.75 that corresponds to this point, and that choice of decision threshold. And we can keep doing that for different thresholds. And we actually are plotting a series of points through the space, which can be connected as a curve. And so in this way, we can get a more complete picture by varying the threshold of how the precision and recall of the resulting classifier output changes as a function of the decision threshold. And this resulting chart here is called a precision recall curve. And we'll look at it in more detail next.